Okay, so last class we ended on page 21, and on page 21 we learned that the number of solutions of a quadratic equation determines how many times your graph will cross the x-intercept. So if you look halfway down the page, it says the number of solutions of a quadratic equation. A quadratic equation has two solutions if the graph of its related function has two x-intercepts or two roots. So if when you graph a quadratic equation it looks like this or like this, it crosses your x-axis twice. Your x-intercepts are called roots, or they are called solutions to the related equation. And if you graph it and it only crosses the x-intercept once, then it's said to have one x-intercept, one root, or one solution. And if, when you graph it, the vertex is above the x-axis and it goes up, or if it's below the x-axis and it goes down, then there will be no x-intercepts and there will be no solutions. Okay? Now, on page 21, we are going to go over finding the zeros of a function. Now remember, finding the zeros of a function mean letting f of x equal 0. That's what finding the zeros of a function mean. Okay? So, here they give us a function. F of x equals negative x squared minus 8x minus 7. And we are going to find the zeros of this function. To do that, I am going to let f of x equal 0. Now, the easiest way for me to find the zeros of the function is to factor it. Now, you know that I like to factor out -1 because when I do my shortcut method, I like that initial coefficient of the first term to be positive. So here I would say x plus 7 times x plus 1 equals 0. Divide both by -1. So either x plus 7 equals 0 or x plus 1 equals 0. And so my two solutions would be -7 or -1. So I get -7 or -1 by factoring. Well, let's see what kind of solution I get by graphing it, the related function. So here I'm going to graph y equals negative x squared minus 8x minus 7. So first I'm going to find my axis of symmetry. And that's negative b over 2a. So that's going to be negative 8 over -2, or x equals -4. So find my vertex, I do f of -4, and that's going to be the opposite of -4 squared, which is 16, plus 32 minus 7. So f of -4 equals 9. And that is my vertex. So I'm going to go to -4 and up 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, from that point, I'm going to use the counting method to graph. I'm going to go over 1, up 1 squared times -1, because a is -1. So it's going to be over 1, down 1 in both directions. Over 2, down 4 in both directions, over 3 and down 1, 2, 3, 4, 5, 6, 7, 8, 9. So when I graph this, I find out that my x-intercepts are -1 and -7. And when I factored it, I found out that my solutions were -1 and -7. So once again, the solutions are -1, -7. The roots are -1, -7. The x-intercepts are -1, -7. And the zeros of the function are also -1, -7. So let's turn the page and do another one. Now, on the next page, they tell us to find the solutions to this equation. So the easiest way to find this solution is to factor it. X minus 9 times x minus 2 equals 0. So my solutions are 9 and 2. Now, I'm also going to graph it to see if my x-intercepts are 9 and 2. So my roots would also be 9 and 2. And as it turns out, they actually graphed it for you. If you look at the picture, your x-intercepts are 2 and 9. So this shows you that your solutions to an equation were 9 and 2. Your x-intercepts of the graph, or your roots, were 9 and 2. And the zeros of the function are going to be 9 and 2. Okay, so you get to fill that in here in your notes. This should be 9 and 2. And when y is 0, this is 9 and 2. And when f of x is 0, this is 9 and 2. Okay, so now the next video you're going to watch is we're going to show you how to solve by using a chart, and then how to solve again by graphing, but this time when your solutions are not always integers.